new topic. Symbols, formulae, and chemical equation. So I welcome you to this new topic, symbol, formula, and chemical equation. Now, why I love chemistry so much is because it always reflects what you have learned earlier before now. But some people find it difficult to understand chemistry. Why? Because they don't have the previous knowledge of what they have learned. Now, following the episode 1, episode 2, episode 3, 4, 5, and so on, reaching to this extent now, you find out that what we are going to do here is almost related to what we have done in the previous one, but they use it for more clarification. That is why you see it part by part or topic by topic in chemistry textbook. Now, when you go to the symbol, what is the meaning of this symbol? What they use to know them? An identification. If I want to know chlorine, what is the symbol or the short form of this chlorine? That's the meaning of what? Symbol. And you have to understand with me that most of them, you cannot pronounce them as you write it. For example, when I want to write iron, you see iron in this form, Fe. So, and when you look at it, and if you want to write it in words, you write I-R-O-N, iron. But why is it that if you want to write it in symbol, we write Fe? That is why I said most of them you don't write it according to how you pronounce it. Why? Because most of them came from Latin word, and that's the reason why we are using that of their Latin name. It's just like when you watch something like water, in Latin we call it aqua. That is water in Latin. Or well, sometimes if you go to Hebrew, they call it hydro. So likewise, all these ones, these elements, most of them was discovered by a Latin scientist and Hebrew scientist, most of them. So because of that, they have to use their Latin language and give the names. Now, for example, let me give you most of the example. Like this iron. Iron in Latin, it is called ferrous. And because of that, we have the symbol as what? Fe. Now, when you go to sodium, for example, we write Na as the symbol of sodium. But when you want to write sodium, you write SOIUM, sodium. But why do we use the symbol Na? We use the symbol Na because it came from a Latin word. And what is this Latin word? Natrium. So these are the things. We have zinc, we have argon, we have many of them that came from Latin word. And they have to use the symbol of that of Latin. For example, also we have what we call potassium. Potassium is Potassium, potassium. But when you want to write the symbol, you write what? K. So why? It came from what? Latin word. And the Latin word of that of potassium is kalium. Kalium, that is potassium. That is why we are using K as the symbol of potassium. Now, here we are going to at least get that of 20 elements or thereabout with their symbol so that you will know them. Now, following the 20 elements which we have counted so far, you have he has light brain but can not offer full 9 subjects. Many arts students prefer such combination, such as physics and chemistry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, let me proceed with other ones. Now, if I want to make it more further, I'll have another one, Mercury, Hg, Hg, which is Mercury, Au, then I have Hg, I have Ag, then I have Sn, then I have Zn, which number again? Then you can also have Cu, copper. Now, what is the meaning of this symbol here? He means helium. Helium. Why H here? Sorry, H here means hydrogen. We have hydrogen. Hydrogen. YHE means what? Helium. YLI means lithium. YBr means beryllium. Be means beryllium. YB means boron. YC means what? Carbon. N means nitrogen. O means oxygen. Please always make sure that the first letter is in capital. YF means fluorine. That is the symbol. The symbol of fluorine become F. The symbol of neon, Ne. Neon is Ne. Neon. Wise, we have this one as sodium. Sodium. YMG is known as what? Magnesium. Al is known as aluminium. Aluminium. Then we have S as silicon. We have P as phosphorus. Phosphorus. We have S as sulfur. Sulfur. Okay, likewise we have Cl as chlorine. Then we have Ar as argon. Then we have P as potassium. Then we have Ca as calcium. Then we have Hg as mercury. We have Au as gold. Then we have Ag as silver. Then we also have Sn. Sn as tin. We have Zn as zinc. We have Cu as what? Copper. I just want to stop here, but you have to know that we have many of them. Symbols, formulae, and chemical equation. Now, these become the elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. And that becomes the first 20 elements. So other ones are additional. Under 20 elements, You will still see mercury, gold, silver, tin, zinc, and copper. So this become the 20 elements with their symbol. So the symbol of hydrogen H, the symbol of helium He, the symbol of lithium Li, the symbol of beryllium Be, the symbol of boron B, the symbol of carbon C, the symbol of nitrogen N, the symbol of oxygen O, the symbol of fluorine F, the symbol of sodium Na, the symbol of sodium Na, while the symbol of neon is Ne. Now the symbol of magnesium Mg, the symbol of aluminum Al, the symbol of silicon Si, the symbol of silicon Si, the symbol of phosphorus P, the symbol of sulfur X, the symbol of chlorine Cl, the symbol of argon Ar, the symbol of potassium K, and the symbol of calcium Ca. This become the symbol that we are talking about. What can you use to note them, so that whenever you see them, you will know what they are talking about? So if we have magnesium tetraoxosulfate 6, you will see Mg means what? Magnesium. Look at the symbol here, magnesium Mg. S means what? Sulfur. You can see it here. O means what? Oxygen. You can see it. So that is how to distinguish each and every one of the elements. Now let's quickly look into what we call formulae. Formulae is just like the formula that occur in element. When you want to write chemical equations, there are formulas that you are going to use. So you cannot just stand up and begin to write formula. It has pattern or method or formats or steps through which you can write the formula of any element that you want to write. Now we have what we call compound. We have compound. We have formula. Compound and formula. Now if I said copper 2 oxide, copper 2 oxide, you see it in this form, CuO, copper 2 oxide. If I said copper 1 oxide, copper 1 oxide, you see it in this form, copper 1 oxide. Mercury oxide, NgO. Now we can also have what we call magnesium chloride. Magnesium chloride, MgCl2. So now the question now is, how come of in copper 2 oxide no 2 here? Why in copper 1 oxide there is 2? Magnesium chloride, I have 2 in the front of chlorine. That is the question, and that is what formulae is talking about. You must use what we call the combining power of an element in this reaction. You must use what we call the combining power, just like what we have in our previous lesson. So we discussed about what we call valency and oxidation. Valency, and that valency becomes what we call the combining power of an element. And that valency is talking about their radicals. And their radicals simply means the group of atoms that possess what? Charges. And that charges belong to the number of electrons that that particular element possesses. That is the meaning of these formulae or valency. Now in that place, I've told you people several times that for you to write formula very well, you must master their valencies. You must also master their oxidation numbers and also their atomic number, because the atomic number of an element is also the valency of that element, but it must be in a radical form. The atomic number of an element is also the valency of that element. Now let's quickly go with this formula. If I may ask, how do I put in copper 2 oxide? Why do I leave it like that? Why in copper 1 oxide I put 2? Now the question is, you first of all consider their radical, the charge that it possesses. When you talk about copper 1, it has a positive charge like this, which is only 1 electron. Then when you talk about copper 2, you will see copper 2 in this form, 2 electrons, electron charges. So because of that, now in copper 2, I have copper 2 oxide. I have my oxygen here, the copper 2, I have my oxygen. And oxygen has also a negative 2 electron charges or radicals. Now with this, I'm going to have 2 and the 2 here. Now we crossing, if I cross these two elements, I'm going to have Cu2, oxygen 2. Cancel this one, I'm going to have copper 2 oxide. That is what it means, copper 2 oxide. Likewise, when you go to copper 1 oxide, you will still use the format copper 1. Since they call it copper 1 oxide, it means that it has 1 valency or 1 radical, positive. Then I also have oxygen with 2. Now, if I cross 2 of them together, I'm going to have Cu2 and O1. 1 times oxygen is the same thing as oxygen, Cu2 and oxygen. And this becomes what we call copper 1 oxide. Likewise, mercury oxide, when you go to their format, is the same method that you use. And magnesium chloride, how do I put magnesium chloride? Magnesium belongs to group 2, that is to say it has 2 valency, while chlorine has only 1, group 7, a negative valency. So that is the radical. When I cross it, 2 of them together, I'm going to have magnesium 1 and chlorine 2. 1 times magnesium still give me magnesium chloride, and this becomes the answer, magnesium chloride. So there must be 2 in the front of that of Cl, because they have carried out what we call exchange of valency, and that is what we call formulae. So you must use all these formula when writing. In case if they give you chemical equation to balance, that is the next one, the chemical equation. If they give you the chemical equation to balance, so you must consider this their valency. For example, if I have iron 2 oxide or iron 2 chloride, suppose they give me iron 2 chloride plus sodium hydroxide. This is the chemical equation now. Supposing that they give me this, so what am I going to have at the end, and how do I balance the equation? Now in this place, you are going to see we have sodium, we have chlorine, we have iron. So in this place, I'm going to have now sodium. This first one, look at this, which is sodium, must go with this last one. Why this first one here will go with this last one? Now in this case, I'm going to have sodium chloride. Now for me to write this sodium chloride, if you watch this place now, you now find out that iron has no 2 in front, but chlorine has. But does not mean that if I want to write the balancing of equation, the product, here become the reactant, this side become the product. It does not mean that if I'm writing this sodium chloride, it will still carry these 2 and go there. No, I must make use of this their valency. How do I make use of it? First of all, you have to be very fast in thinking. Now, sodium belongs to group 1, yes, and has 1 electron valency, while chlorine belongs to group 7 and has negative 1 valency. So if 2 of them combine, you are going to have Na1 Cl1. 1 times Na is the same thing as Na. 1 times Cl, which is chlorine, is the same thing as what? Chlorine. So there is no 2 in front. Don't mind this 2 that is here. Why this chlorine carry 2 here is because of iron 2 chloride where they combine. So if it is combining with this side, you are not going to write 2 any longer. You must master formulae. Now I'm going to have sodium chloride plus iron 2 hydroxide. Iron 2 hydroxide. So this will become my product. But the fact is this, is the equation balance is the next. So if I want to balance the equation, though we still meet balancing of chemical equation as we move ahead to the next lesson. Now here I have iron 1. When you go to the product side, 1. I have chlorine here, how many? 2. Whereas in the product side is what? 1. So it's not balanced. So I have to make this one what? 2. Now how do I make it to be 2? I will put 2 here. 2 times Cl will give me 2 chlorine. Now in this case, sodium here is 1, while sodium here is 2. So sodium is not balanced. So put 2 here. When you put 2 here, it means that sodium is now 2, while sodium is what? 2. Now where we have hydroxy. Hydroxy is how many? 2. Oxygen is 2. Go to this side, oxygen is what? 2. Hydrogen is how many? 2. And hydrogen is what? 2. Make the equation balance. So you can find out that now I have balanced the equation, which is most students find it difficult. But when you use this method, because if you put 2 here, you will find it difficult to balance. Why? Because it will not rhyme to the balancing of the chemical equation. So you must master the formulae. The formulae will not give you the idea of the chemical equation. So this is where we are going to call it a day for this chemical equation. Now waiting for me next time as we proceed. We'll treat more further on. As we go more further, you will see other aspect or other method or how to balance chemical equation, which we are going to meet in our next lesson. Thank you very much, and God bless.